Hey YouTube, welcome back. Today we have this problem called longest palindromic substring. Um, the problem goes that given a string S, return the longest palindromic substring in S. And a substring is a contiguous non-empty subsequence of characters within a string, and a palindrome is a string that is you can read it forward and backward the same. It doesn't change. For example, the pep is the palindromic because we can read it backward and forward the same, and a substring is a continuous string from a specific string. So let me continue. Let me just bring something. And today we will solve this problem in dynamic programming. And before I go through this solution, I just want to say this solution is not easy. It's pretty difficult to understand. So, and there is no good way to try to describe it other than just try to code it directly and talk about the code. So if you find yourself you can't understand what's going on, just breathe, take a deep breath, and just watch the video over and over. And if it was completely unclear for you, feel free to give me a comment about what you didn't understand exactly, so I can describe it to you. Therefore, just to continue, so basically in dynamic programming, what I'm thinking about is that I will create a table, and this table will represent every index, and compared to all the other indexes that can be substring and palindrome with it. And after that, I will try to loop through it and through the extra string and compare it with the table. So let's just try to see how we will do this one. So I just want to put some variables that we will use over and over. So let n equals s.length. Okay. I will create a table here. I'll call it db, and it will be array dot from. Okay, it will be from first of all length. It will be in, and we will have we will fill each element with another array because it will be table, so it will be two-dimensional array. It will be array of n, and we will fill it with false values. Okay, and we will have our own answer array in S. Let's call it ANS, and it will equals at the beginning 0 and 0. The first, I will store every element as in the table. I will put true for it. That means we have this index, and this index could be a start of palindrome. So let's see how they will do this one. I will do for loop, let I equals 0, I less than n, I plus plus, and I will say db of I again will equals true. Okay, so what we're doing here, let's just have this on table. We have this table right now. Okay, and it represents like I, it will be represent here, and J will represent here. And I will start with I first. I will say this true. Okay, true, for example. And if J also equals this I, if like the next J or the next element, okay, equals I, that means we have a new we have a new palindrome, because if this element equals its next, that means we can read it backward and forward the same. So we will try to do this one also as a true. And let me, if I guess it's not easy to understand this one. What's going on? What's going on? Let me refresh. Maybe I need to refresh. Okay, so if you don't understand this one, just be with me. After that, I will create a loop. I start every starting of like I here will represents the start of palindrome, like a dbi of I. It will represent the start of every specific palindrome. And I'm putting true because the start it will be true, and I'll try to find the end for the palindrome. So I will say let I again here. Let's call it j will equals 0. No, let's call it I. Let I equals 0. I less than n minus 1 and I plus plus. And what I'm doing here, I'll say if s of I equals s of I plus 1. If that was true, that means we have a palindrome, because if s of I, sorry, s of I all the time forget this one. So basically, if this db of I, or like not d, no, go back. So basically what we're doing here, we're looping through s, okay, and we're saying that if this string equals its next, so we will try to update the table. We'll try to update the table with next element was true, so it will be db of I and I plus 1 will equals true. And I will add the ns here. The ns will be ns will equals the answer. It will be the answers is represents the start and the end of the palindromic string substring. So it will be I and I plus 1. So if you can see here, we'll try to find any two length string, any palindromic string with length of 2, because this will make our life way more easier. After that, we do another loop. We'll say for let it will be difference, which will be equals 2, and I will say the difference is less than n, and difference plus plus, and I will say for let I equals 0, I less than n minus difference, and I plus plus. And right now we loop here because we want to compare every character with all its different characters. So basically we start from 2 because we have already stored any palindromic with a length of 2, and we start from there. We don't have to loop it again. And I will say first I'll get a const g will equals I plus the difference, and this one let's just make if s of I equals s of j and db if s of I equal to s of j and db of I plus 1 and db of I plus 1 of G minus 1, that means the previous element, this previous character of G, if it's equals true and these characters equals each other, that means that we have a palindrome. So what we do, we update the table, so it will be db of I of G will equals true, and ns equals I of I and J, and after that in the end I will return the start and end. I will give something called start and end. It will be a const. I will get the first element as start, the second element it will be end from ans, and I will return s the substring start and output end plus plus 1. If you don't understand anything, just that's reasonable. It's takes me so much time to try to understand this problem also. So let's just try to describe the code, and after that let's try to run example. We could run this example to see how this will look like. So first let's just try to see what we have here. We have the longest palindromic function takes a string s as an input and returns the longest palindromic substring found with s. We initialize a dynamic programming table called db, where dbi of j is dbi of j represents whether the substring from the index I to j is a palindrome or not. The code iterates through the string s to mark a single character as a palindromes by setting db I of I to true in all i's. Okay. Also, we check for palindromic of length 2 and updates I dbi of index I plus 1, and ans the variable storing the indexes of the longest palindrome found so far. Accordingly, we update it with that also. After that, the code iterates through the string to find the palindrome of length greater than or equal to 3, and we check if the characters at the current position, which is s of I and s of g, are the same, and if the substring within those positions, db of db I plus 1 and db g minus 1 is palindrome. So if it sets we set db j of I to true and updates ans within the current indices. After computing the iterations, we extract the start and end of the indices of the longest palindromic found in ns. And finally, we return the longest palindromic substrings by substring within the extract indices. Let me just run example, because if we run example, maybe it will be easier to understand. So let's say that we have this input right now, and our n. Let's just say our n will equals how much our n will equals? N will equals is the length 1, 2, 3, 4, 5. Okay, and we have ans, which equals still 0 and 0, and we have our table, and our table db, it's an array of arrays, and it's array of 5 arrays. So array, we have 1, 2, 3, 4, and 5. Okay, and we also fill it with the length, all of its length. It will be all false, So let's just start to do this one. I guess it will be better to do it like that. So let's just make it here. False 1, false 2, false 3, and false 4, and false 5. Let me copy all of that and store it in all the other arrays. So this is our on table right now. So we start with the db first here. db I of I will equals true. So when I equals 0 and it will be 0 of 0, this one will be true. And 1 of 1, this one it will be true. 2 of 2, this one will be true. And 3 of 3, this one will be true. And endly 4 0 1 2 3 and 4, this one will be true. Okay, so right now we have these true. I want to color them actually though to can be able to see them. However, let's continue. So I will loop again, and I will loop through the string here, and I will say if I equals I plus 1. Let's try to see I equals I plus 1 here. I here, this does I equals I plus 1? I plus 1, no. Okay, if I equals plus 1, no, no. Okay, does I equals I plus 1? No. Actually, there is no I equals I plus 1. No I equals I plus 1, so it doesn't do anything here. I plus 1, I plus 1. And here I plus 1, no, 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 it's not working. Let me bring that because we will use it here a lot. So we loop again here, and we loop with difference. So we couldn't find any palindromic with 2, so we try to find a palindromic with 3. So what we are going to do here is just find here j. It will equals 0 plus 2, it will equals 2 at the beginning. Okay, so we say, okay, if s of I equals s of j, s of I 0 equals s of j. Okay, that's true. This is true. This is true. This is true. Okay, and b and b. And we want to say and if s and db of I plus 1, which will be I plus 1, it will be 1. We are in this array. And j minus 1, so we talk about this one. It's true, and this is right. It is true. That means, okay, so what that means, I'm saying if this character equals the last character, and all the middle characters also, they can be palindrome. And because of the middle character is only one character, so it's just palindrome because it will, we compare it to itself. Because of that, we stored every single starting of I as a true, because this will be starting of a palindrome. So if that was true, we update I of j, db I of j, which will be 2. Let me just 0 and 2 here. This will be true. And we'll update ns will be and ans will be I or I and j. So ns will be here 0 and 2. Okay. And we continue looping. Okay, we have we continue looping, and I guess we could find ABA or BAP, but like just a stop here. We continue looping. Let's see that we'll find any new palindrome. We can find ABA, but like, let's see that we'll not find any new palindrome. So right now we have starts and ends would be 0 and 2. and we return them, and we add 1 because we want to include 2. So basically we return this one because the palindrome starts here. Also there is a new palindrome that when we loop, it will be in ABA here. This one, it will be true also because it will be the same here actually. It will be true. No, it will be like, no, it will be true from here to here. True. Yeah, it will be like that. So basically we'll use our table to just try to track the palindrome, and every table represents the start and the end of the palindrome. And this solution is way more better than the previous one because this one have O of n squared. The previous one had O of n power of to power of 3. So it's way more better and way more professional solution. So let's just delete all of that and just submit the code and see if it's working or not. Okay. Oh, it's not good. It's beating 26%. Okay. Not bad. Okay, so that's it for this video, and I hope my description is quite good. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss a video, and see you in future problems.